To find a missing angle in a right triangle, we're going to use inverse trig functions. These are the buttons you see on your calculator. If you were to hit second sign, for example, you see the little -1. That's an example of an inverse trig function. So the way it works is very similar to what we did to find missing sides. Let's take a look at the angle that we want to find, so this angle. I want to identify the sides then as opposite, adjacent, or hypotenuse, same as before. So the 11 is the hypotenuse, the 6 is the adjacent side. I don't know the opposite side, but that's okay, I don't need it. If I wanted to find it, I could do Pythagorean theorem, but that's not necessary. So taking a look at the sides that I have, the adjacent and the hypotenuse, I want to think back to SOHCAHTOA and figure out which part uses A and H. And that's going to be the K part of SOHCAHTOA. So what that's telling me is I'm going to do cosine. So in this case, the equation I'll write is cosine, and I always do cosine of the angle. This time I don't know the angle though, so it's cosine of theta, equals the adjacent side, 6, over the hypotenuse, 11. So that's the equation we're setting up when we're finding missing angles. To undo this, to get theta by itself, I need to do the inverse cosine. So the inverse cosine, make sure you're using parentheses on your calculator for 6 over 11. You can make that into a decimal if you want to, but there's really no reason to do it. I want my angle in degrees this time. Nothing said that, but we usually measure angles in degrees in a triangle. So make sure you're in degree mode or you'll get an answer in radians. Let's go ahead and round to 2 decimal places. I can see that this angle comes out to be about 56.94. Now since it's degrees, make sure you have a degree symbol, or I'm going to assume it's in radians. Okay, it's that easy. If I want to find the other angle, I could subtract from 180 or do another trig problem. Let's go ahead and do an application problem with this as well. So in this case, we're building a ramp for a hospital. So let's go ahead and make a quick sketch of what's going on here. So there's my ramp. That might be a bit steep. They asked me to find the angle of elevation. Remember, that's always measured from the horizontal. So the angle of elevation is the angle down there. So that's what I want to find. Now, sometimes the wording in this can be a bit tricky. So let's do our best to make sure that our numbers end up in the right spot. It tells me that my ramp must rise 8 feet for every 20 feet in length. So in this case, they're kind of giving me a rise over a run. So I'm going to say a rise of 8 for a run of 20 feet. Now, sometimes people want to put the 20 there because they talk about the ramp being 20 feet in length. And I guess sometimes it can be a bit ambiguous. So do your best to read the problem carefully and try to identify what's going on and what numbers go where. So I'm going to assume the numbers go this way in this case because it's kind of like a rise over a run. So anyway, here's the angle I want to find, that angle of elevation. So let's identify the names of our sides. This side over here then would be the opposite, and this side down here would be the adjacent. So thinking back to SOHCAHTOA and figuring out which part uses O and A, that's tangent this time. So I'm going to do tangent of the angle. This time I don't know it, so tangent of theta is equal to the opposite side, 8, over the adjacent side, 20. And once again, since I'm finding a missing angle, I'm going to do an inverse trig function to find this. So the inverse tangent is what I'll do to undo that, of 8 over 20. If you want to simplify 8 over 20, you can. There's, again, really no reason to, so I can just leave it as is. That angle for this wheelchair ramp comes out to be about 21.80 degrees. Make sure you've got the degree symbol if you're working in degrees.